Hello, in this lecture we'll find out the radius of the biggest circle. In the drawing we have four circles. Those three circles are located inside the biggest circle. We know that the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units. The radius of this circle is equal to 1 unit. And we want to find out the radius of this circle, the biggest circle, that the other three circles are located inside it. Okay, so first of all, actually when two circles are tangent to each other, there are two types of tangency between two circles. Two circles can touch each other at one point in two different ways. The first way that two circles can touch each other is they can touch each other externally, like in this drawing. This type of tangency is defined as external lunge. Those two circles are touching each other at point S, this point, externally, and it is defined as external lunge. And here the radius of the small circle is equal to small r, and the center of the small circle is located at point M, while the radius of the big circle is defined as capital R, and the center of the big circle is at point O. So the distance between the centers of those two circles is equal to OM, and OM is equal to R plus 1R. OM is equal to capital R plus small r. And actually OM is equal to OS plus SM, and OS plus SM is capital R plus small r. So whenever two circles are tangent to each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r. So the external lunge, this is defined as external lunge. The external lunge is the first type of tangency, and we have also the second type of tangency between two circles that is actually defined as internal lunge. When two circles are touching each other internally, like in this drawing, it is defined as internal lunge. Actually, those two circles are touching each other at point S internally. Point S is the point of tangency, and the distance OM between the centers of those two circles equals to OS, that is capital R, minus SM, that is small r. That is to say, OM equals to capital R minus small r. So in conclusion, when two circles touch each other internally, then the distance between their centers, in this case OM will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus small r. And the first type of tendency is the external lunge, when the two circles are touching each other at one point externally. Then the distance between the centers of the two circles will be equal to the sum of the lengths of their radiuses. That is to say, in this case it will be equal to capital R plus small r, while in the case of internal lunge, the distance between the centers here will be equal to capital R minus small r. Okay, this is to say, it will be equal to the difference between the lengths of the radiuses. In this case, is capital R minus small r. Okay. So here we will return to our original drawing, and we will define the center of this circle that its radius is 4 units as point A. We will define the center of this circle that its radius is equal to 9 units as point B. And we will define the center of this circle that its radius is equal to 1 unit as point C. And we will also define the center of the biggest circle, this circle, as point O. And we will define the radius of the biggest circle as capital R. I'll write it here. Capital R is the radius of the biggest circle, this circle. As you can see here in the drawing, we have the straight line. This straight line is tangent to those three circles at 3 points. We define the first point of tendency between the straight line and this circle as point D. Point D is the touching point between this straight line and this circle, or we can define it as the point of tangency. So I write it here. Point D is the point of tangency between the straight line and this circle. Likewise, we will define the point of tendency of the straight line with this circle as point E. So I write here that point E is also the point of tendency of the straight line with this circle. Likewise, we define the first point of tendency of this straight line with the smallest circle as point F. Again, point F is also the point of tendency of this straight line with this small circle. In the next step, we will join points A and D together by a straight line. Actually here AD is defined as the radius of this circle. Why? Because it starts from the center of the circle, that is to say point A, and ends at point D. This is a point on this circle itself, therefore AD is defined as the radius of this circle, that is to say it's equal to 4 units. Likewise, we will join points B and E together by a straight line. Again, line segment BE is the radius of this circle, that is equal to 9 units. 9 units. Why? Because it starts, line segment BE starts from point B, that is the center of this circle, and ends at point E, that is the point on this circle itself. Therefore, BE is defined as the radius of this circle. That is to say, it equals to 9 units. So BE equals to 9 units. And we join points C and F together by a straight line. Here CF is the radius of the smaller circle because of the fact that it starts from the center of the circle, that is to say from point C, and ends at point F, that is a point of the circle itself. Therefore CF is the radius of this circle, that is to say it equals to 1 unit. CF equals to 1 unit. And in the next step, I will present to you a new rule. Rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD. It is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of the straight line with this circle. Therefore, according to rule number 1, the tangent FC will be perpendicular to the radius AD, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius BE of this circle that is drawn to the point of tendency, that is to say, it is drawn to point E, that is the point of tendency of the straight line with the radius BE. Therefore, according to rule number 1, the tangent FD will be perpendicular to this radius EB. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And here also we have the radius CF that is drawn to the point of tendency, that is to say, it is drawn to point F, that is the point of tendency of the straight line with the radius CF. Therefore, the tangent DF will be perpendicular to the radius FC, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so in the next step, we will draw perpendicular from point A to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point A and BE as point P. And we will focus on quadrilateral APDE. Here in quadrilateral APDE we have 3 right angles, 1, 2, 3. So in quadrilateral APDE, we have three right angles, and the sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, the size of this angle, this is actually angle PAD. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that angle PAD is equal to 360 degrees minus 270 degrees is equal to 90 degrees. Angle PAD equals to 90 degrees. So we can write here that this angle PAD equals to 90 degrees. So because of the fact that quadrilateral APDE has four right angles, therefore quadrilateral APDE is a rectangle. I'll write it down. Quadrilateral APDE is a rectangle and we know that the opposite sides of a rectangle are equal to each other. So I write it down. We have the rule that the opposite sides of a rectangle are equal to each other. So here, according to this rule, AD equals to PE, AD equals to PE, but we know that AD equals to 4 units because it is the radius of this circle, so AD equals to 4 units. And from this equation, 4 equals to AD equals to PE, we will conclude that PE also equals to 4 units. PE equals also to 4 units. So I can write here that PE equals to 4 units. In the next step, we will draw perpendicular from point O to DE. Again, from point O, we draw perpendicular to DE. So here this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees, and we will define the touching point between the perpendicular from point O and DE as point M. And we will focus on quadrilateral A, and we will define the intersection point of the straight line OM and AP as point S. And we'll focus on quadrilateral ASDM. In quadrilateral ASDM, this quadrilateral, we have three right angles. The sum of three right angles is 270 degrees, plus the size of angle ASM, this angle. In total, the sum of those two angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, the sum of the angles in quadrilateral ASDM must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that angle ASM, the missing angle, will be equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle ASM is a right angle, and OM is the perpendicular from point O. So OM, the line segment OM is perpendicular, it is absolutely a straight line. So we can write down that OM, line segment OM, is a straight line. Line segment OM is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then according to the rule that I mentioned, the sum of the angles at point S must be equal to 180 degrees. So which angles we have at point S at this side of the straight line OM? We have here 90 degrees, and we have also this angle that is actually angle OSA. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of the straight line is equal to 180 degrees. So here we subtract 90 degrees from this equation and we get that angle OSA is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OSA equals to 90 degrees. You can write here that angle OSA equals to 90 degrees is a right angle. And so we will focus on quadrilateral SPME. In quadrilateral SPME, yeah. In quadrilateral SPME, we have three right angles, 1, 2, 3. The sum of three right angles is 270 degrees, so 270 degrees plus this angle that is actually angle MSP. In total, the sum of those four angles must be equal to 360 degrees. So, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we subtract 90 degrees from this equation and we get that angle MSP is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So we get MSP equals to 90 degrees. So actually, quadrilateral SPME is four right angles, and therefore quadrilateral SPME is a rectangle. I write it down. Quadrilateral SPME this quadrilateral is a rectangle and according to the rule that the opposite sides of a rectangle are equal to each other, we will get that PE equals to SM. P equals to SM, but P equals to 4 units. P equals to 4 units. So from this equation, 4 equals to P equals to SM, we will conclude that SM also equals to 4 units. We can remind you that SM equals to 4 units. So as you can see here, quadrilateral ASDM has 4 right angles. Therefore, quadrilateral ASDM is also a rectangle. So, quadrilateral ASDM is a rectangle. And we already found out that quadrilateral APDE is also a rectangle. So, in conclusion, we actually have 3 rectangles. Quadrilateral SPME is a rectangle, quadrilateral ASDM is a rectangle, and quadrilateral APDE is also a rectangle. And what is the size of BP? The size of line segment BP you can see it easily from the drawing that BP is equal to BE minus PE. I'll repeat again. BP equals to BE minus EP or PE. So BP equals to BE is the radius of this circle that equals to 9 units. Minus PE that equals to 4 units. So in conclusion, we found out that BP equals to 9 minus 4, that is 5. So BP equals to 5 units. We write here that BP equals to 5 units. In the next step, we will join points A and B together by a straight line. what is the value of line segment AB? A is the radius, A is the center of this circle that its radius is 4 units. B is the center of this, B is the center of this circle that its radius is equal to 9 units. Those two circles have an external launch between them. At this point they are touching each other. Therefore, the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radii. And the sum of the lengths of their radii is here. This radius is 4 units, and this radius is 9 units. So 4 plus 9 is 13. So we found out that the length of line segment AB is equal to 13 units. So we'll focus on the right triangle ABP. In the right triangle ABP, we actually implement the Pythagoras theorem on the right triangle ABP. So here, in the right triangle ABP, according to PT is the abbreviation of Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to BP squared plus AP squared. I repeat again, in the right triangle ABP, according to the Pythagoras theorem, AB squared must be equal to BP squared plus AP squared. So here AB equals to 13 units, therefore AB squared is 13 squared. 13 squared is 169. Equals to BP squared. BP equals to 5 units, so BP squared is 5 squared. 5 squared is 25. Plus AP squared. AP is the missing variable, so we will leave it as it is, AP squared. So in conclusion, we found out that 169 equals to 25 plus AP squared. Here we'll subtract 25 from this equation, and we'll get that 169 minus 25 is 144, equals to AP squared. Here we'll take a root out of this equation. So AP equals to the square root of 144, and the square root of 144 is 12. AP equals to 12 units. So we can write here that AP equals to 12 units. AP equals to 12 units. And we've already found out that quadrilateral APDE is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, AP equals to DE. AP equals to DE. But we just right now found out that AP equals to 12 units. So from this equation, 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. So we can write here that DE, line segment DE, equals to 12 units. We will define ME as X. So ME equals to X according to our definition. Here we write that ME equals to X. And what is the value of DM? The line segment DM will be equal to DE minus ME equals to DM. DE minus ME equals to DM. I'll repeat again. DM equals to DE minus ME. So DM equals to DE, that is 12 units, minus ME, that is equal to X according to our definition. So in conclusion, we found out that DM equals to 12 minus X. So we can write down that DM equals to 12 minus X. But we have already found out that quadrilateral ASDM is a rectangle. I'll repeat again. We have already found out that quadrilateral ASDM is a rectangle because it has 4 right angles. From the fact that quadrilateral ASDM is a rectangle, we will conclude that DM equals to AS. DM equals to AS. But we just right now found out that DM equals to 12 minus X. dm equals to 12 minus x. So from this equation, we conclude from this equation 12 minus x equals to dm equals to as. We conclude that as also equals to 12 minus x. as equals to 12 minus x. Now you can write down that as equals to 12 minus x. Likewise, we have already found out that quadrilateral SPME is a rectangle, and therefore the opposite sides of rectangle SPME are equal to each other. That is to say, ME equals to SP, ME equals to SP in rectangle SPME. In rectangle SPME, ME equals to SP, but ME equals to X according to our definition. ME equals to X. So from this equation X equals to ME equals to SP, we will conclude that SP also equals to X. SP also equals to X. So we write here that SP equals to X. In the next step, we will define OM as Y. So OM, the perpendicular OM is equal to Y according to our definition. Again, OM equals to Y. So what is the value of OS? OS, you can see it easily from the drawing, that OS equals to OM minus SM. Again, OS equals to OM minus SM. So OS equals to OM, and OM is equal to Y according to our definition, minus SM, and SM equals to 4. So in conclusion, we found out that OS equals to Y minus 4. So here we can write down that OS equals to y minus 4. So we will focus on the right triangle OAS, and we'll implement the Pythagoras theorem on the right triangle OAS. So I'll copy again the right triangle OAS in a new page, and we'll implement the Pythagoras theorem on this right triangle OAS. But before that, we'll calculate the value of line segment AO. What is the value of line segment AO? A is the center of this circle that its radius is equal to 4 units. O is the center of the biggest circle that its radius is equal to capital R. And those two circles have an internal length between them at this point. The biggest circle and this circle are touching each other at this point. Therefore, whenever we have two circles with an internal length between them, then the distance between their centers, this is to say AO, will be equal to the difference between the lengths of their radii. The radius of this circle is equal to 4 units, the radius of the biggest circle is equal to capital R, and the difference between those radiuses is equal to capital R minus 4. So, in conclusion, we found out that AO equals to R minus 4. So, I draw the right triangle AOS, the given right triangle AOS in this new page. And if we know that AES DM is a rectangle, therefore AES also equals to 12 minus x, like DM. The opposite sides of a rectangle are equal to each other, that is to say DM equals to AES, therefore AES also equals to 12 minus x, we did it here. AES equals to 12 minus x. and triangle AOS is a right triangle. This angle is equal to 90 degrees. So we'll implement the Pythagoras theorem on this green right triangle, triangle AOS. So in the right triangle, triangle AOS, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. AO is the hypotenuse, so the square of the hypotenuse is AO square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OS square plus AS square. Again, in the right triangle AOS, according to the Pythagoras theorem, AO square equals to OS square plus AS square. So we can write here that according to equation number 1, AO square is R minus 4 square. R minus 4 square and it equals to OS square. OS is Y minus 4, so OS square will be equal to Y minus 4 square plus AS square. AS equals to 12 minus x, so AS square will be equal to 12 minus x squared. Here we will open the brackets on both sides of equation number 1 and we'll get that R minus 4 square is R square plus 16 minus 8R and it equals to Y minus 4 square. Y minus 4 square is equal to Y square plus 16 minus 8Y plus 12 minus x square. 12 minus x square is equal to 144 plus x square minus 24x. So here we have 16 on both sides of equation number 1, so 16 will get cancelled. We add 8R to this equation number 1. And we get that R square equals to 8R minus 8Y plus 144 minus 24x plus x squared plus y squared. Here we subtract x squared and y squared from this equation number 1, and we will get that according to equation number 1, r squared minus x squared minus y squared is equal to here we have 8r minus 8y. We will take 8 as a common factor out of those two expressions. So it will be 8 times r, capital R minus y, plus 144 minus 24x. So in conclusion, we found out that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. In the next step, we will draw perpendicular from point O to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point between the perpendicular from point O to BE as point T. So I will draw triangle OBT in a new page, and we will implement the Pythagoras theorem on this green triangle, triangle OBT. Okay. So this is the green triangle, is triangle OBT, and we have quadrilateral OMET. In quadrilateral OMET, we have 1, 2, 3 right angles, and the sum of three right angles is equal to 270 degrees plus the size of the fourth angle that is actually angle MOT in total. The sum of those four angles must be equal to 360 degrees. Here we'll subtract 270 degrees from this equation and we'll get that the size of angle MOT is equal to 360 degrees minus 270 degrees is 90 degrees. So we actually found out that this angle MOT is equal to 90 degrees. Therefore, quadrilateral OTME is a rectangle. Quadrilateral OMET is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to OT. ME equals to OT. I'll repeat again. The opposite sides in rectangle OMET are equal to each other. That is to say, ME equals to OT. But ME equals to X according to our definition. So, from this equation X equals to ME equals to OT, we will conclude that OT also equals to X. OT also equals to X. We write here that OT equals to X. Likewise, in rectangle OTME, OM equals to TE. OM equals to TE. The opposite side OM is equal to TE. But according to our definition, OM equals to Y. So from this equation, Y equals to OM equals to TE, we will conclude that TE also equals to Y. So we can write here that TE equals to Y. And what is the value of BT? The value of line segment BT, you can see it easily from the drawing, that BT equals to BE minus TE. And we already know that BE equals to 9 units. This is the radius of the circle that equals to 9 units. So BT equals to BE minus TE. BT equals to BE minus TE. So BT equals to BE is 9 units, TE is Y. So in conclusion, we found out that BT equals to 9 minus Y. And what is the value of line segment OB? Here, the value of line segment OB. O is the center of the biggest circle that its radius is equal to capital R. B is the center of this circle that its radius is equal to 9 units. Here, BE equals to 9 units, and this circle and the biggest circle have an internal notch between them at this point. That is to say, they are touching each other internally at this point. This is the point of tangency between those two circles. Therefore, the distance between their centers, that is to say OB, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus 9. So in conclusion, we found out that OB equals to capital R minus 9. OB equals to capital R minus 9. Now we can implement the Pythagoras theorem on the right grade triangle, triangle OBT. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle OBT is OB. So the square of the hypotenuse is OB squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to, according to the Pythagoras theorem, to BT squared plus OT squared. By PT, that is the Pythagoras theorem. I'll repeat again. According to the Pythagoras theorem, OB squared must be equal to BT squared plus OT squared. OB equals to R minus 9, so OB squared is equal to R minus 9 squared. And it equals to BT squared. BT equals to 9 minus Y, so BT squared is equal to 9 minus Y squared. Plus OT squared. OT equals to X, so OT squared will be equal to X squared. So we found out that R minus 9 squared equals to 9 minus Y squared plus X squared. Here we will open the brackets on both sides of this equation, equation number 2, and you will get that according to equation number 2, r minus 9 squared is equal to r squared plus 81 minus 18r, that equals to 9 minus y squared, 9 minus y squared is equal to 81 plus y squared minus 18y plus x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and we will add 18 now to this equation, equation number 2, and we will get that r squared equals to 18r minus 18y plus x squared plus y squared. Here we subtract x squared and y squared from this equation, equation number 2, and we will get that according to equation number 2, r squared minus x squared minus y squared equals to 18r minus 18y here we'll take 18 as a common factor out of those two expressions, and we will get that according to equation number 2, r squared minus x squared minus y squared equals to, so 18 was taken as a common factor, so inside the brackets we will have r minus y. So in conclusion, we found out that according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. In the next step, we will draw perpendicular from point C to BE. So this angle equals 90 degrees, and this angle is also equal to 90 degrees. So here in quadrilateral, so we define the touching point between the perpendicular from point C to BE is point Q. So here in quadrilateral QCEF, in quadrilateral QCEF, we have one, two, three right angles, and the sum of three right angles is 270 degrees, plus the size of angle QCF. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation, and we found out that the size of angle QCF is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So angle QCF is a right angle, therefore quadrilateral QCF has four right angles, and therefore quadrilateral QCEF is a rectangle. Quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, QE equals to CF. QE equals to CF. But CF equals to 1 unit. It is the radius of the smallest circle. CF equals to 1 unit. From this equation, QE equals to CF equals to 1. We will conclude that QE also equals to 1 unit. So you can write down that QE equals to 1 unit. In the next step, we will join points B and C together by a straight line. What is the length of line segment BC? The length of line segment BC, we know that B is the center of this circle, that its radius is equal to 9 units, while C is the center of the smallest circle, that its radius is equal to 1 unit. And those two circles have an external length between them. At this point, they are touching each other externally at this point. This is the point of tangency. So whenever you have an external length between two circles, then the distance between their centers, that is to say, in this case is BC, will be equal to the sum of the lengths of their radii. And the radius of this circle is equal to 9 units. The radius of this circle is equal to 1 unit, and the sum of the length of the radii will be equal to 9 plus 1, that is 10 units. So we found out that BC equals to 10 units. BC equals to 10 units. And what is the value of BQ? So here I can write down, I will copy the triangle BQC in a new page. In this page, and we will see it clearly in the new page. So this is the right triangle PQC. We know that quadrangle QCEF is a rectangle, and we know that BE equals to 9 units because it is the radius of this circle. So what is the value of BQ? Actually, BQ equals to BE minus QE. I'll write it down. BQ equals to BE minus QE. So BQ is equal to BE, that is 9 units, minus QE, that equals to 1. So in conclusion, we found out that BQ equals to 9 minus 1, that is 8. So BQ equals to 8 units. BC equals to 10 units. So now we can find out the missing side, that is actually QC, by implementing the Pythagoras theorem on this right triangle BQC. So in the right triangle BQC, according to the Pythagoras theorem, we will get that the square of the hypotenuse, that is actually BC squared, must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PQ squared plus CQ square. BC equals to 10 units, so BC square is 10 square, 10 square is 100, equals to BQ square. BQ equals to 8 units, so BQ square is 8 square, 8 square is 64, plus CQ is the missing variable, so we leave it as it is. We subtract 64 from this equation, and we get that 36, 100 minus 64 is 36, equals to CQ square. We'll take a root out of this equation, and we'll get that CQ equals to the square root of 36. The square root of 36 is 6. So we found out that CQ is equal to 6 units, and according to the rule that the opposite sides of a rectangle are equal to each other, we will get that QC is equal to EF. QC is equal to EF. But we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we will conclude that EF is also equal to 6 units. EF equals to 6 units. So here, you can write here that CQ equals to 6 units and EF also equals to 6 units. In the next step, we will draw perpendicular from point C to OM. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we'll define the touching point between the perpendicular from point C to OM as U. And what is in quadrilateral COMF, we have 1, 2, 3 right angles. Actually, we have 4 right angles in quadrilateral CFUM. 1, 2, 3, 4. So quadrilateral CUMF is a rectangle because of the fact that it has 4 right angles. Quadrilateral CUMF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM. CF equals to UM. According to the rule that the opposite sides in a rectangle are equal to each other, we get that CF equals to UM. but we know that CF is equal to 1 unit. CF equals to 1 unit, so from this equation 1 equals to CF equals to UM, we will conclude that UM also equals to 1 unit. So we can write here that UM equals to 1 unit. Likewise, UC will be equal to MF equal to the other UCMF. UC will be equal to MF. But MF equals to X plus 6. MF equals to X plus 6. MF equals to X plus 6. So from this equation UC equals to MF equals to X plus 6, we will conclude that UC also equals to X plus 6. UC also equals to X plus 6, so UC equals to X plus 6. We will join points O and C together by a straight line. I will draw the right triangle OUC in a new page, and we will implement the Pythagoras theorem on this right triangle OUC. So this is the right triangle OUC. The green right triangle OUC. So what is the value of side OU? You can see it easily from the drawing that side OU equals to OM minus UM. OU equals to OM minus UM. So OU is equal to OM, that is Y according to our definition, minus UM. We just right now found out that UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. So we can write here that OU equals to Y minus 1. And what is the value of OC? The value of OC, O is the center of the biggest circle that its radius is equal to capital R. C is the center of the smallest circle that its radius is equal to 1. Those two circles have an internal notch between them at this point. They are touching each other at this point. So whenever you have two circles that are touching each other internally, then the distance between their radii will be equal to the difference between the lengths of their radii. The length of the radius of the biggest circle is equal to capital R. The length of the radius of the smallest circle is equal to 1. And the difference between those two radii is capital R minus 1. In conclusion, we found out that OU is equal to capital R minus 1. So now we can implement the Pythagoras theorem in the right triangle OUC. So according to the Pythagoras theorem, the square of the hypotenuse, this will be a question number 3, the square of the hypotenuse is OC squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OU squared plus UC squared. Okay, so according to equation number 3, with Pythagoras theorem, we get that OC squared equals to OU squared plus UC squared. So here OC is equal to R minus 1, so OC squared will be equal to R minus 1 squared, and it equals to OU squared. OU is equal to Y minus 1, so OU squared is Y minus 1 squared plus UC squared. UC equals to X plus 6, so UC squared will be equal to X plus 6 squared. So here we'll open the brackets on both sides of equation number 3. According to equation number 3, R minus 1 squared equals to Y minus 1 squared plus X plus 6 squared. So according to equation number 3, R minus 1 squared is R squared plus 1 minus 2R, that equals to Y minus 1 squared. Y minus 1 squared is equal to Y squared plus 1 minus 2Y plus X plus 6 squared. Here X plus 6 squared x plus 6 squared is equal to x squared plus 36 plus 12x So in conclusion, we found out that according to equation number 3, r squared plus 1 minus 2r equals to y squared plus 2y minus 2y plus x squared plus 36 plus 12x. Here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2r to this equation number 3, and we will get that according to equation number 3, r squared equals to 2r minus 2y plus 36 plus 12x plus x squared plus y squared. Here we subtract x squared and y squared from this equation number 3, and we'll get that according to equation number 3, r squared minus x squared minus y squared equals to here 2r minus 2y. Will take 2 out as a common factor, out of those two expressions as a common factor, and we get the 2 times inside the brackets. We have r minus y plus 36 plus 12x. So in conclusion, we found out that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. This is equation number 3, and according to equation number 2, we found out that r squared minus x squared minus y squared equals to 18 times r minus y, and according to equation number 1, we've already found out that r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. So here we will compare equation number 1 to equation number 2, or we can create equation number 4 that states that r squared minus x squared minus y squared according to equation number 1 must be equal to r squared minus x squared minus y squared according to equation number 2. So according to equation number 4, r squared minus x squared minus y squared according to equation number 1, that is actually equals to 8 times r minus y plus 144 minus 24x must be equal to r squared minus x squared minus y squared according to equation number 2, that is actually equals to 18 times r minus y Here we will subtract 8 times r minus y out of this equation, equation number 4. We subtract 8 times r minus y from equation number 4. And we will get that according to equation number 4, 144 minus 24x equals to 10 times r minus y Here we'll divide equation number 4 by 10. And we'll get that according to equation number 4, r minus y equals to 144 minus 24x over 10. We will divide both the numerator and the denominator on this side of equation number 4 by 2, and we get that according to equation number 4, r minus y equals to 144 over 2 is 72, minus 24x over 2 is 12x, over 10 over 2 is 5. So in conclusion, we found out that r minus y according to equation number 4 equals to 72 minus 12x over 5. We will create equation number 5 that states that r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. So r squared minus x squared minus y squared according to equation number 2 is 18 times r minus y, and it must be equal to r squared minus x squared minus y squared according to equation number 3, that is actually equals to 2 times r minus y plus 36 plus 12x. So here we'll subtract 2 times r minus y from this equation, equation number 5, and we will get that 18 times r minus y minus 2 times r minus y is 16 times r minus y equals to 36 plus 12x. Here we will divide this equation, equation number 5 by 16, And we'll get that according to equation number 5, r minus y equals to 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we'll get that according to equation number 5, r minus y is equal to 36 over 4 is 9. 12x over 4 is 3x. 16 over 4 is 4. So in conclusion, we found out that r minus y according to equation number 5 is equal to 9 plus 3x over 4, while r minus y according to equation number 4 is equal to 72 minus 12x over 5. So in the next step we will create equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. So equation number 6 states that r minus y according to equation number 4 that equals to 72 minus 12x over 5 must be equal to r minus y according to equation number 5 that is actually equals to 9 plus 3x over 4. Here we will cross multiply equation number 6 and we will get that according to equation number 6 4 times 72 minus 12x equals to 5 times 9 plus 3x. We'll open the brackets on both sides of equation number 6 and we'll get that according to equation number 6 4 times 72 is 288 minus 4 times 12x is minus 84x. That equals to 5 times 9 is 45 plus 5 times 3x is 15x. Here we subtract 45 from this equation, equation number 6, and we'll get that according to equation number 6, 288 minus 45 is 243. That equals to 48x plus 15x is 63x. We will divide this equation, equation number 6, by 9. And we will get that 63 over 9 is 7, so 7x equals to 233 over 9 is 27. We'll divide this equation, equation number 6 by 7, and we'll get that according to equation number 6, x equals to 27 over 7. in the next step, we'll put the value of x inside equation number 5. Equation number 5 states that r minus y equals to 9 plus 3x over 4. So we'll substitute x by 27 over 7 because x equals to 27 over 7 in equation number 5. So here we get that r minus y according to equation number 5 equals to 9 plus 3 times x, and x is 27 over 7 all divided by 4. So actually, according to equation number 5, we found that r minus y is equal to 3 times 27 is 81 over 7. We'll multiply 9 by 7 and then we'll divide it by 7 in order to have a common factor with this expression. So 9 times 7 is 63 plus 81 over 7 all divided by 4. So we got actually that r minus y according to equation number 5 equals to 63 plus 81 is 144 over 4 times 7 is 28. We'll divide both the numerator and the denominator of this expression by 4. 144 over 4 is 36 and 28 over 4 is 7. So in conclusion, we found out that r minus y according to equation number 5 is equal to 36 over 7, and we already found out that x according to equation number 6 is equal to 27 over 7. So in the next step, we will put the value of x and r minus y inside equation number 2. And according to equation number 2, we know that r squared minus x squared minus y squared is equal to 18 times r minus y r squared minus y squared is equal to r plus y times r minus y, according to the algebraic identity that states that a squared minus b squared equals to a squared minus b squared. So here we will substitute r squared minus y squared by r plus y times r minus y minus x squared equals to 18 times r minus y. Here we will add x squared to this equation, equation number 2, and we will get that according to equation number 2, r plus y times r minus y equals to x squared plus 18 times r minus y. We found out that r minus y according to equation number 5 equals to 36 over 7, while x according to equation Number 6 is equal to 27 over 7. So here we will substitute r minus y. We will substitute r minus y in question number 2 by 36 over 7, and we will substitute x, or x squared, by 27 over 7 squared. Okay. So we get that according to equation number 2, r plus y times r minus y, and r minus y equals to 36 over 7. That equals to x squared, and x equals to 27 over 7. So x squared will be equal to 27 over 7 squared plus 18 times r minus y, and r minus y equals to 36 over 7. So here we will multiply this equation number 2 by 7, and we get that according to equation number 2, r plus y times 36 is equal to 27 times 27 over 7. 1 7 will get cancelled, we go to multiply it by 7. We multiply equation number 2 by 7, so here 7 will get cancelled, and we get that it equals to plus 18 times 36. So here we'll divide this equation number 2 by 9, and we'll get that 36 over 9 is 4, so here we'll get 4 times r plus y is equal to 27 over 9 is 3, so here we will have 7 times 20, 3 times 27 over 7 plus 18 over 9 is 2, and 2 times 36 is 72. Here 3 times 27 is 81, so I write it down. We get that 4 times r plus y is equal to 3 times 27 is 81 over 7, and here we will multiply 72 by 7, then we will divide it by 7 in order to have a common factor with 81 over 7. So we get that according to equation number 2, 4 times r plus y is equal to 81 plus 72 times 7 is 504 over 7 over 7. So 81 plus 504 is 585 over 7, that equals to 4 times r plus y. Here we divide this equation number 2 by 4, and we will get that r plus y is equal to 585 over 7 times 4 is 28 This is according to equation number 2. And we've already found out that according to equation number 5, r minus y equals to 36 over 7. Here we multiply both the numerator and the denominator on this side of equation number 5 by 4, and we get that r minus y according to equation number 5 equals to 36 times 4 is 144 over 7 times 4 is 28. So according to equation number 5, so according to equation number 2, we found out that r plus y is equal to 585 over 28, when according to equation number 5, we found out that r minus y is equal to 144 over 28. So here we will add equation number 2 to equation number 5, and we will get that r plus r is 2r, y plus minus y is y minus y, that is 0, and it equals to 585 over 28 plus 144. So we got that 2r is equal to 585 plus 144 is 729 over 28. We'll divide this equation by 2, and we'll get that the radius of the biggest circle that we are looking for equals to 729 over 2 times 28 is 56 units, or in terms, you can represent it also as 13.018 units. So you can write down that the radius of the biggest circle is equal to either 729 over 56 units, or we can represent it as 13.018 units. That is the answer to the question, that the radius of the biggest circle equals to either 729 over 56 units, or we can present it as also that the radius of the biggest circle equals to 13.018 units. In the next step, I will summarize the lecture. Okay? So, in the drawing we have 4 circles and 3 circles are located inside the biggest circle. We know that the radius of this circle equals to 4 units, the radius of this circle equals to 9 units. The radius of the smallest circle, this circle, is equal to 1 unit. And we want to find out the radius of this biggest circle that the 3 other circles are located in. Okay? So, first of all, I presented to you two new terms. Whenever two circles are touching each other, we have two different tangencies between two circles. The first tangency is the internal lunge. Here, those two circles are touching each other internally at point S, this point. They are tangent to each other at this point, that is point S. The center of the small circle is at point M, and the radius of the small circle equals to small r. The center of the big circle is at point O, and the radius of the big circle is equal to capital R. And the distance between the centers of those two circles is OM. What is the value of OM? You can see it easily from the drawing, that OM equals to SO. OM equals to SO minus SM. OM equals to SO minus SM, and SO equals to capital R. SM equals to small r. So in conclusion, we found out that OM equals to capital R minus small r. So whenever you have an internal lunge between two circles, that is to say they are touching each other internally, like in this drawing, then the distance between their centers, in this case is OM, will be equal to the difference between the lengths of their radii. In this case, it is equal to capital R minus small r. And we have also a second type of tangency between two circles. The second type of tangency between two circles is the external lunge. The external lunge is when the two circles are touching each other at one point externally, like here, those two circles are touching each other externally at one point at point S. And in this case, the distance between their centers, that is to say MO, will be equal to the sum of the lengths of their radii. That is to say, OM equals to MS plus SO. OM equals to OS plus SM, it is the same. That is to say, it equals to capital R plus small r. Again, OM equals to capital R plus small r. So whenever you have two circles that are touching each other externally, then the distance between the centers will be equal to the sum of the lengths of their radii. In this case, it is equals OM or MO equals to capital R plus small r, and whenever two circles are touching each other internally, then the distance between their centers will be the difference between the lengths of their radii, that is to say, in this case, will be equal to capital R minus small r. Then I presented to you but before that, actually, we defined the center of this circle, that its radius is equal to 4 units at this point A. We define the center of this circle, that its radius, is equal to 9 units as point B, and we defined the center of the smallest circle, that its radius is equal to 1 unit as point C. We defined the center of the biggest circle, the radius that you are looking for, as point O, and again, according to our definition, the radius of this biggest circle is equal to capital R. Then we defined the first point of tendency of this straight line if this circle is point D. We defined the second point of tendency of the straight line if this circle is point E. And we define this third point of tendency of the smallest circle with the straight line as point F. Then we join together points A and D by a straight line. The radius AD is the radius of this circle because of the fact that line segment AD starts from the center of this circle, that is to say from point A, and ends at point D, that is the point on this circle itself. Therefore, line segment AD is the radius of this circle because of the fact that this is exactly the definition of a radius. The radius starts from the center of the circle and ends at any point on the circle itself. So AD is the radius of this circle, that is to say it equals to 4 units. Then we join points B and D together by a straight line. Again, for the same reasons, line segment BE will be the radius of this circle because it starts from the center of the circle and ends at point E, that is the point of the circle itself. Therefore, line segment BE is the radius of this circle, that is to say it equals to 9 units, and for the same reason, CF, we join point C and F together by a straight line, and CF is the radius of the smallest circle, that is to say it equals to 1 unit. Okay, and then I presented to you a new rule that is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD that is equal to 4 units. The radius AD is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of the straight line with this circle. Therefore, according to rule number 1, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius AD. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have the radius BE that is equal to 9 units. It is drawn to the point of tendency. That is to say, it is drawn to point E, that is the point of tendency of the straight line with this circle. Therefore, according to rule number 1, the straight line will be perpendicular, the straight line FD or the tangent FD will be perpendicular to the radius BE, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. For the same reasons, exactly, we get that here this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And in the next step, from point A, we go perpendicular to DE. So this angle equals to 90 degrees and this angle equals also to 90 degrees. We define the touching point between the perpendicular from point A to BE as point P. We focused on quadrilateral APDE. Quadrilateral APDE has 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this angle PAD. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral must be equal to 360 degrees. Again, we have the equation that says that 270 degrees plus the size of angle BAD must be equal to 360 degrees, according to the rule that I mentioned. We subtracted 270 degrees from this equation, and we got that angle BAD equals to 90 degrees. So this angle is a right angle, and because of the fact that this angle is a right angle, quadrilateral APDE has 4 right angles. Therefore, quadrilateral APDE must be a rectangle. So, we also have the rule that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle AD, PE, AD equals to PE. AD equals to PE, but AD equals to 4 units. It is the radius of this circle. From this equation, 4 equals to AD equals to PE. We will conclude that PE also equals to 4 units. So here, PE equals to 4 units. Then, actually, in quadrilateral AES-DM, we have 1, 2, 3 right angles. and the sum of three right angles is 270 degrees, plus the size of this angle that is actually angle ASM. In total, the sum of those four angles in quadrilateral ASTM must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle ASM equals to 90 degrees. That is to say, this angle is a right angle equals to 90 degrees, and actually we have here in quadrilateral ASDM four right angles, therefore quadrilateral ASDM is a rectangle, and also from point O, after we do perpendicular to DE, this again equals to 90 degrees and this again equals to 90 degrees, so actually OM is perpendicular to DE. OM is a perpendicular, must be a straight line. Again, OM is a straight line because it is a perpendicular, and we have the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So the sum of the angles on this side of the straight line OM at point S must be equal to 180 degrees. Which angles we have at this side at point S, the straight line OM, we have here 90 degrees, and we have also angle OSA, and according to the rule that I mentioned, the sum of those two angles must be equal to 180 degrees. So angle 90 degrees plus the size of angle OSA, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle OSA equals to 90 degrees. Here, angle OSA, this angle is a right angle, it equals to 90 degrees, therefore, actually the green triangle OAS must be equal, must be a right triangle because it has one angle that is a right angle. Okay, and then so ADEP is a rectangle. We have already proved that ASMD is also a rectangle. And what is left here? Quadrilateral SPME. In this quadrilateral, the green quadrilateral SPME, we have three right angles, 1, 2, 3. Here, actually, we do perpendicular from point A to BE, so this is a right angle. So we have here 1, 2, 3 right angles, plus the size of angle MSP. In total, the sum of those four angles must be equal to 360 degrees. Okay, quadrilateral SPME, 270 degrees plus the size of angle MSP. In total, they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle MSP is equal to 90 degrees. This angle MSP, is equal to 90 degrees. Therefore, quadrilateral SPME is a rectangle. Quadrilateral SPME is a rectangle, and we have already found out that quadrilateral ASOM is also a rectangle, and quadrilateral ADPE is also a rectangle. So all three quadrilaterals here are rectangles. So quadrilateral SPME is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, PE must be equal to SM. But PE equals to 4 units. PE must be equal to SM, but PE must be equal to 4 units. So from this equation, 4 equals to PE equals to SM, we will conclude that SM also equals to 4 units. Here SM equals to 4 units. Okay? So what is the value of BP? BP is equal to BE minus PE. Again, BP equals to BE minus PE. So BP equals to BE, that is 9 units, this is the radius of this circle, minus PE, PE equals to 4. So in conclusion, we found out that BP equals to 9 minus 4. 9 minus 4 is 5. So BP equals to 5 units. So we can write here that BP equals to 5 units. Then we focus on the right triangle, triangle ABP. So BP equals to 5 units. But what is the value of AP? The value of AB? AB, A is the radius of this, is the center of this circle, that its radius is equal to 4 units. B is the center of this circle, that its radius is equal to 9 units. Those two circles have an external notch between them. At this point they are touching each other externally. Therefore, the distance between their centers, that is to say AB, will be equal to the sum of the lengths of the radii, that is to say it will be equal to the radius of this circle plus the radius of this circle, that is to say it will be equal to 4 plus 9. 4 plus 9 is 13, so we found out that AB equals to 13 units. Then we implemented the Pythagoras theorem on the right triangle, triangle ABP. According to the Pythagoras theorem on the right triangle, triangle ABP, AB square equals to BP square plus AP square. In the right triangle, triangle ABP, AB square equals to BP square plus AP square. AB equals to 13, so AB square is 13 square. 13 square is 169. BP equals to 5, so BP square is 5 square. 5 square is 25 plus AP square. Here we subtracted 25 from this equation, and we found out that 169 minus 25 is 144. 144 equals to AP square. We took a root out of this equation, and we found out that AP equals to the square root of 144. The square root of 144 is 12. So AP equals to 12. We found out that AP equals to 12 units. And then we have already found out that quadrilateral APDE is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say AB equals to DE. AP equals to DE. But we just right now found that AP equals to 12 units. So for this equation 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. Here DE equals to 12 units. Then we defined MF as X. MF equals to X according to our definition. And what is the value of dm? dm will be equal to de minus me. dm equals to de minus me. So dm equals to de, that is 12 units, minus me, that is x. So in conclusion, we found out that dm equals to 12 minus x. Okay, so here dm equals to 12 minus x, but we have already found out that ASDM is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, DM equals to AS. DM equals to AS according to the rule that the opposite sides of a rectangle are equal to each other. But we just right now found out that DM equals to 12 minus x. So from this equation 12 minus x equals to DM equals to AS, we will derive that AS also equals to 12 minus x. Here AS equals to 12 minus x. Likewise, we have already found out that quadrilateral SPME is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to SP. In rectangle SPME, ME equals to SP. But ME equals to x according to our definition. So from this equation, x equals to ME equals to SP, we will conclude that SP also equals to x. So here we can write down that SP equals to x. We defined OM as y. Again, OM equals to y according to our definition. So what is the value of OS? You can see it easily from the drawing that OS is equal to OM minus SM. Again, OS equals to OM minus SM. Again, OS equals to OM minus SM. OM equals to y according to our definition. SM equals to 4 units. So in conclusion, we found out that OS equals to y minus 4. Here OS equals to y minus 4. Then I do the right triangle AOS in a new page, and we implemented the Pythagoras theorem on the right triangle AOS. So we found out that OS equals to y minus 4, and we've already found out that AS equals to 12 minus x. So what is the value of AO? AO, the value of line segment AO. A is the center of this circle that its radius is equal to 4 units. O is the center of the biggest circle that its radius is equal to capital R. And those two circles, the biggest circle and this circle, have an internal notch between them. At this point they are touching each other internally. Therefore the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus 4. So we found out that AO equals to capital R minus 4. So here we can implement the Pythagoras theorem in the right triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AO, so the square of the hypotenuse is AO square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OS square plus AS square. Okay. So here AO equals to R minus 4, so AO square is R minus 4 square. Y OS square equals to Y minus 4, so OS square equals to Y minus 4 square. And AS equals to 12 minus x, so 12 minus, so OS square will be equal to 12 minus x square. We opened the brackets here and we found out in conclusion that R square, according to equation number 1, R square minus x square minus y square equals to 8 times R minus y plus 144. Then from point A, we do perpendicular to OM. So this angle equals to 90 degrees, this angle is equal to, actually from point O, we go perpendicular to BE. So this again equals 90 degrees, this again equals to 90 degrees. And we define the touching point between the perpendicular from point O to BE as point T. So I draw triangle, the right triangle OBT in the green color in a new page, and we implemented the Pythagoras theorem on this green right triangle OBT. So here, what is the value of OT? We know that quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other. ME equals to OT and ME equals to X, so OT will be also equal to X. And what is the value of BT? BT equals to BE minus TE. BT equals to BE minus TE, and OM equals to TE because of the fact that quadrilateral OTME is a rectangle, so OM equals to TE. But OM equals to Y according to our definition, therefore TE will be also equal to Y. So here BT equals to BE minus TE. BT equals to BE minus TE, so BT equals to BE, that is 9 units, minus TE, that equals to Y. So in conclusion, we found out that BT equals to Y. And what is the value of OB? The value of OB, O is the radius of the biggest circle, O is the center of the biggest circle, that is radius is equal to capital R. B is the center of this circle, that its radius is equal to 9 units. And those two circles have an internal length between them. At this point they are touching each other, therefore the distance between their circles, the distance between their centers will be equal to the difference between the lengths of the radii, that is to say it will be equal to capital R minus 9. So here this capital R minus 9, so we implemented the Pythagoras theorem on this right triangle OBT. So OB square equals to BT square plus OT square, and we found out that we actually found out that according to equation number 2, R square minus X square minus Y square equals to 18 times R minus Y. Then from point C, we go perpendicular to BE. So this angle equals 90 degrees, and this angle equals to 90 degrees. We defined the touching point between the perpendicular from point C to BE as point Q. And here, actually quadrilateral QECF is a rectangle, and the opposite sides of a rectangle are equal to each other, that is to say CF equals to QE, but CF equals to 1, so QE will be also equal to 1. And what is the value of PQ? PQ equals to BE minus QE, that is to say BQ equals to BE, that is 9, minus QE, that is 1, so BQ equals to 8 units. And what is the value of BC? We have here two circles with an external length between them, therefore the distance between their centers will be equal to the sum on the length of the radii, that is to say it will be equal to 9 plus 1, that is 10. So actually we use the Pythagoras theorem on the right triangle QBC, and we found out that QC equals to 6 units. QC equals to 6 units. Therefore EF will be also equal to 6 units. And quadrilateral QCEF is a rectangle, and therefore QEF also equals to 6 units. And from point C we draw perpendicular to OM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the touching point between the perpendicular from point C to OM as U. And actually UCMF is a rectangle, therefore UC equals to CF equals to 1 unit, and UM is equal to MC, that equals to X plus 6. So here we implemented the Pythagoras theorem on the right triangle OMC. According to the Pythagoras theorem, here OC square equals to UO square plus UC square. So R minus 1 square equals to Y minus 1 square plus X plus 6 square. So we got here 3 equations. We solved the 3 equations, and we found out that the radius of the biggest circle is equal to either 729 over 56 units, or in terms of numbers it equals to 13.018 units. Again, the radius of the biggest circle equals to either 729 over 56 units, or we can present it as that the radius of the biggest circle equals to 13.018 units. Okay, thank you very much.